Well, radian measure. All right. So radian measure is just another way of looking at angles. It's like if you were measuring a distance and you were looking with feet and meters. They're just two different sets of units. They obviously are quite different from one another, and you can't really interchange them. You can go between them, but you need to make sure that you're using the right conversions. So we always want to remember that a radian measure is the measure of an angle, not a distance, but we do use a lot of distances when we're trying to find radians. A radian measure is defined as the length of a arc that subtends the angle divided by the radius of a circle. So really what we're looking at is this is a arc that's subtending between these two lines. Okay, so we've got our angle, it's being subtended, and we've got the radius of the circle. Okay, now the important kind of formulas that we need to remember about this is that if we think about a circle, the circumference of a circle is 2 pi r. Okay, it's going to go all the way around the circle. And it's important to use the 2 pi r formula because we do have radius when we're talking about radians. That actually allows us to find the length of the circle that's between that angle. So we call that the arc length. Now the arc length is the angle times the radius, which makes sense because when we're looking at this, the radian is actually the angle or the length of this divided by the radius gives us that angle. So if we multiply by the radius, it's going to give us that length again. And it's always got to be in radians. Okay, we can't use degrees, and that's a common mistake. We need to make sure we change over to radians. Now the conversion from radians to degrees is quite easy. To go from radians to degrees, we just multiply by 100 and divide by pi. Now to go from degrees to radians, which is probably more important and you need to know how to do it more readily, we divide 180 and then multiply by pi. Just kind of a side note, 1 radian is about 57 degrees, and 1 degree is about 0.017 radians. Okay, it's not really anything that you need to memorize, but it is just showing the two different conversions. So oftentimes the term radian or rad is omitted, so it's not like degrees where you have to put the little degree symbol. If there's no symbol written, then it's assumed that it's in radians. Sometimes radians are given with respect to pi, and that's normally when it's an exact number. So you wouldn't see like 6.28, you would see 2 pi. Okay, 6.28 is rounded, 2 pi is not. So if we were determining the exact and approximate radian for each measure, so what I've done is I've gone through and done the approximate. So this is 0.524. Okay, so I divided by 180 and multiplied by pi. So if I was looking at this and I divided it by 180, well, 30 divided by 180 is going to reduce down to 1 over 6. So there we go, hold on. Come on, 1 and then over 6. And it would be 1 over 6 pi, or pi by 6. Alright, so I'm just going to be really slow going through this. Now I'm not going to do the exact measure for all of these. I'm going to just do this one here. So it would be 1 over 6 pi, which changes to pi by 6. Pi by 6. And that's actually one of our special angles, if you remember 30 degrees, and we'll talk about that later. 45 degrees is also a special angle. The approximate is 0.785. I want you to go and try to do the exact by yourself. It should be with respect to pi. Okay, now at the bottom here, we're going to have approximates again. We'll just measure to the nearest degree because we are getting rid of that pi. So we're going to take pi, multiply by 180, and then divide by pi. So pi over 3 times 180 divided by pi. It's going to give us 60 degrees. Now here, again, that's a special angle, so it works out nice. Here it doesn't work out as nice. We get 336, but that is rounded. Okay, so finally a couple applications to this. So Tommy goes on a carousel ride. We realize the horse is 9 meters from the center. That is telling us the radius of the circle. So that value right there is telling us the radius. So instantly I'm thinking that it's going to be some sort of radian question, probably with a length. So if the carousel travels through an angle of 5 pi by 6, find the arc length. Well, or find the length of the arc, which is just arc length. So we've got our formula, and it's got to be in radians, which is nice because this is in radians. And all we have to do is multiply by the radius. So we're going to take our 5 pi, I didn't write the pi symbol in, so 5 times 3.14 divided by 6 times 9, we get 23 meters. So the length of that arc would be 23 meters. Now the last question here, I'm going to set up the first one and solve it for you, but the second one I'm going to leave, so the radians per second I'm going to leave for you guys to do on your own. When we're looking at angular velocity, we're talking about how much something's spinning around in a circle. Okay, so the hard drive of a computer rotates at 7,200 revolutions per minute. Determine the angular velocity in degrees per second and radians per second. So the first thing we need to realize is that we have to multiply by 60 because we need to go from revolutions per minute to revolutions per second. Now when I'm looking at degrees, if I'm going a whole revolution, that's a whole circle, there's 360 degrees in a circle. So I'm going to have to say 1 revolution is 360 degrees. So I'm going to have to take my number and multiply by 360 degrees, and I get, 155520000, and that would be degrees per second. So I didn't put a unit in there, but degrees per second. Ooh. Now you guys are going to go through and you're going to do the radians on your own, and we will take that up in class tomorrow.